Welcome back, Naji here. So let's set the agenda of this tutorial. So here we'll be planning to cover basic PyTorch workflow. So we'll be creating or we will be preparing a data and we'll be loading the data and we'll be building a model in PyTorch and we'll be training the model and we'll be saving the model to the physical location. Then we will be loading the model. So this is the basic workflow that we are planning to do in this video. Okay, so here this is very simple for in this video, but this is the basic building block or building block like when we consider the PyTorch model building. Okay, so the same structure will be followed whenever we go to the CNN or whenever we will be building any custom models, but there will be definitely there will be some additions, but this is the core idea behind this. Okay, so understanding this workflow is very important. Okay, so I have created a notebook and other rather than writing it like a online, like I prefer to have a notebook ready so that like we can go very fast and we can discuss areas which needed more discussion time. Okay, so here I have installed matplotlib. Okay, so let me execute it, and here we can see we are doing some import packages, right? So the torch is importing and I am importing torch dot from torch we are importing the nn. So nn is a module that is specifically for creating or building the neural network, and we are importing the PLT also, I mean matplotlib also. Matplotlib will be used for creating the graph. Okay, so in this tutorial, as I said, we will be creating a basic workflow with respect to model training, building and saving all those things. So for that we will be using a linear regression model. So everybody knows the basic algorithm of linear regression, that is m is equal to y is equal to mx plus c, where we can say m can be considered as a weight and c can be considered as a bias. Okay, so the next step we are going to build a training data set or a test or a data set for us. Okay, for that let's think that our weight is 0.7 and our bias is 0.3. Okay, and here I'm giving some value, and based on this value we are creating the y and we are creating also x value. Okay, so first step is I'm going to create a x value. For that what I am doing, we are creating a start and end, and we are setting the step size. So start will be 0 and end will be 1 and step size will be 0.02, and we will be using torch.arrange. This is we discussed in our last video, and I'm just creating some data between 0 and 1 and step size is 0.02. Okay, so once we have the data using this weight and bias, I'm creating a y value. Okay, so let's execute this. We have the y value based on this weight and bias, and let's print and see some values of x and y, some values of x and y. So we can see that the x value is 0.02 and y value is 0.300, etc. So next, once we have the data, then what happens in the training process? So next step is we need to split this into training and test data. Here we are calculating 80% of 80% of our x value, right? So let's print it. So which means I believe we have the like 60 records will be there around. Okay, the total length. So in which like we are taking 80%, that is a 40, not 60. Let me take entire length of the x value. Length of x will be 50. Okay, so we have 50 records will be there. So in that 50 records we are taking 80% of records as a training data. So here we are see 40 records we are taking as a training data. Okay, so based on that we are splitting the data, like x train, y train and x test, y test will be splitting based on the train split. So let's execute this. Let's print x train and y train, which is 40 each, and if you look on the x test and the y test, we will have the 10 each. Okay, and next is we are creating a supporting a utility function which will help us to plot the data. Okay, so here we have the x train, y train, x test, y test, and if we have any prediction value, that is also can be passed. So let me execute this. Let's run it. Okay, so here we can see the dotted in blue lines will be the training data, and dotted with green lines will be the testing data. So if you look on here, so we can see the 40 records will be the training data, and remaining 10 records will be our testing data. Okay, so now we can build our model. Okay, so before going to build, let's understand what we are going to do. Okay, so we have the test data. Okay, so based on this training and test data, we need to predict weight and bias. Okay, in this scenario we know that our weight and bias is 0.7 and 0.3. Okay, but in our real scenario usually we will have the x and y value. Based on this x and y value we need to predict this weight and the bias. Okay, let's see how can we do that. So let me scroll it down. Okay, so this is the building process. So here we are actually building a model in PyTorch. Okay, as I said, in all the scenario this is the basic step that we need to follow, but definitely there will be like some variations with respect to use case to use case. Okay, so here I am declaring a variable, I mean a class, a defining class like linear regression model, and this is importing nn.Modules. So this is a package that is supporting, or that is responsible for building a neural network. Here we are initializing, and these are the two important lines. Okay, here we are initializing the self.weight and self.bias. So here we are setting nn.parameters, and we are setting as a random value, some random value to weight, and we are also similar in bias, we are giving some random values. Okay, and here we can see we are keeping the data type as a float, and we make the required grade as true, so which will help us to the what we call the calculate the gradient. Okay, so once that is done, we have to define a forward function. Okay, so in a neural network what is actually happening is that we will have a forward propagation will be there, right? So in the forward propagation we have to define some algorithm here, some formula here. So here we define the linear regression formula, that is self dot x into weight into x value plus self dot bias. So this is the algorithm that is executing when we do the forward pass. Okay, so let's execute it. Okay, then we can see we can define, or we can create a model, linear regression model. Then I am going to predict the model with the x data. Okay, let's see. Okay, so I have the prediction data, and I can see by default what is the value of weight and what is the value of bias. So for that I can use model.stateDict to print the values. So let's print it. So we can see that the weight value will be 2.20, and the bias value is minus 0.95, right? But what is our original value? So if you scroll it down, we can see that our original value is 0.2 and 0.3, right? Okay, so let's scroll it down. Okay, then what we can do, we can just execute the diagram and we'll see our values. Okay, so this is the prediction value. So this is the same diagram as I shown here, only thing is that we are adding the prediction value also. So this is our the blue lines will be our train data, green lines will be our test data, and this red dot will be our prediction data. Okay, so if you look on this prediction data is not accurate, right? This should be very close to this green line. Okay, so now like we didn't do any training, but after training I will show you how can we change these values close to the green line. Okay, now let's scroll back. Okay, so this is a basic neural network workflow. Okay, what is a forward pass and what is a backward pass? This is very high level. Okay, so what happens in the forward pass? So in our case, linear regression, our algorithm or our formula is y is equal to mx plus b, right? So internally what is happening? So we will have an input like x, okay, and we will have a weight will be there, and what happens is that we will be calculating mx m into x will be calculated here, and we will have a bias will be there, and there will be another node, so that will be calculating mx plus b. Okay, so result will be in called as a y hat. Okay, so that is a prediction. Okay, then once the prediction is done, we will calculate the loss. Okay, so what is a loss? Loss is, in a simple way, we can see that the difference between the predicted value and the actual value. For example, if my predicted value is 5 and my actual value is 4, the loss will be 1. Okay, so in a very layman way, but that is not actually true, but to understand, that is what we call the loss. Okay, so once we have the loss, so this is what we call the forward pass. Okay, so what will happen in the backward pass? So in a backward pass, we will calculate the so this is actually, we are applying the chain rule, and we are calculating the gradient, and the gradient will be propagated back to the parameters. Okay, so that is what is happening in the back propagation. Okay, so this will be done by, so we are calculating the loss, and in the back propagation we are calculating the gradient, and we are updating this back to the parameters. So this is done through the optimizer. Okay, so there are two terms that we discuss. One is the loss, and we discuss about the optimizer also. So purpose of the loss is to calculate the loss, and the gradient. So in the back propagation we will calculate the gradient, and the optimizer will update the parameter values. Okay, so that is what is happening in the forward pass and the backward pass. So in a training loop, we will exactly execute these steps. Okay, so I will show you how can we do that. Before that, how can we convert this into a PyTorch? So this is in a generic step. So what are steps that we need to do if we are coding in a PyTorch? Okay, so in a PyTorch training loop, we will have a forward pass. So in a forward pass, internally it will trigger a forward method that we have created. So we have created y is equal to y is equal to mx plus c algorithm, right? That will be executed when we call the forward. Okay, so internally PyTorch will call the forward method. So we don't need to actually call the forward method. We just need to create the model, and we just need to say model, and we have to pass the x.train. So once we pass this internally, it will trigger the forward method. So once the forward method is done, so next is we need to calculate the loss, right? So I just mentioned here, we need to calculate the loss. Okay, loss can be calculated using a loss function. So I will tell you how can we declare that. If you have a loss function, we just need to pass y predict minus y train. So we will get the loss will be calculated here. Okay, so once the loss is calculated, I'm just skipping the third part. I will tell you that later. And once that is done, we will do a back propagation. So that can be done using loss.backward. So if you do that, the gradient will be calculated. And after that, once the gradient is calculated, we will be calling optimizer.step. So this will update all the gradient to a new value. Okay, so that is what happening when we do the optimizer.step. Okay, so this is a training loop, right? So consider first loop is done. Then when we are coming to the second loop, okay, so when we coming to the second loop, the gradient has some default values or some values that is got from the earlier loop, right? So we need to ensure that we have to make the gradient as 0 before we do the back propagation. Otherwise it will be miscalculated. Okay, for that we have to do optimizer.0grade. Okay, so that is why we are using this particular step 3, which will ensure that we are making the gradient to 0. Okay, so basically these are the 5 steps that we will be executing in PyTorch. Okay, so let's execute this line. So here we are creating a loss function. So here we can see I am using the L1 loss, and there are a lot of loss functions are there, but for the time being just look into this. So we have a L1 loss that we are using, and here we are creating a optimizer. So we are using a stochastic gradient optimizer, and this optimizer is connected with our model parameters, because then only it will be able to update the values with the parameters. Then here I am doing the learning rate. So let's execute it. Okay, Now we can discuss a little bit more about the optimizer and this learning rate. For that, I have a file, a tutorial. Okay. So let's understand this, how the optimizers work. Okay. So here, consider this is the optimizer formula, weight update formula. So here what it does is it is actually calculating the new weight, right? While we run the optimizer the step, or while we update in the gradient, it will creating a new weight. Okay. So in our case, what happens is that we have a old theta is there. So old theta is something like maybe 0.2 point something, right? So that is our old theta. Then we are calculating some gradient here. Okay, so that is happening internally. Then we are multiplying this with this alpha. Okay, so this alpha is called the learning rate. Okay, so there is some importance with respect to learning rate. Learning rate is actually controlling the new value of theta. Okay, so I will show you how that is happening. Okay, so let me reset this. Okay, so here these are the three images that with different values of alpha, that is learning rate, that is 0.001 and 0.1 and 0.9. okay, and consider there are three images. So what is our goal? Okay, so understand that we are here in the red point and we need to reach to the central point. Okay, so that is the minimum optimal value. Okay, so if my learning rate is 0.001, this will go to like each small step. Okay, here we can see from 0 the one green line and one green dot. Okay, this is very slowly converging to this minimum point. Okay, and if our theta is 0.1, here we can see the step size is little big, right? Little big, it will come here and it will little big, something like that. It will reach the optimal value. Okay, so if the learning rate is too big, like 0.9, here we can see first from the red it will jump to here, right? Then it will jump to here, then it will jump to here, and it will jump to here. Okay, so this too large is not recommended. Okay, so what is the problem with the too large? For example, it is jumping from here to here, here to here, then maybe from here it may jump to here. Okay, so it may miss the center point. Okay, then we have to go back and forth like multiple times to get the optimum value, but that is also a little difficult if the learning rate is too big. So if the learning rate is too small, we will reach the optimum value, okay, but it will be too slow. So it is always recommended to optimal value between 0.001 to 0.1, and 0.1 can be considered as optimal value based on the data set. Again, like we have to try it out to get the optimal value. Okay, now let's do some animation here. So you can see that this is still coming, right? Executing. Okay, so this is coming very slowly. Let me reset it again. Let's execute this, right? Okay, so I believe visually it is very clear, right? Now go back to our code. Okay, so loss is defined, optimizer is defined, and let's see what is our current model state. Okay, so our model state is 2 point something and the bias is 0.9. Okay, now what we are going to do, we are going to run, or we are going to train our model. First we are going to do with the 100 epochs. Okay, then this is the training loss, and we have a test loss, and we have a epoch count. So these are the two lists that we are keeping for a recording purpose, or keeping the history. The train loss value, we will keep the loss value of training data, and this is the loss value for test data, and this is the epoch count. So what we are going to do, we are going to run this loop for 100 times. Okay, so first step is we are making it as a model.train. Okay, so we are saying that okay, you are going to train the model, so it will set internally, it will set few things for the model training. Okay, and this is the default set also. So once the model is ready for training, we will do a prediction, model.xtrain. Okay, so this is a training phase, that is why we are using the model.xtrain, model xtrain. So internally, as I said, this will call our forward method and it will calculate y is equal to mx plus c. So we will get some result, the prediction result. So once we have the prediction result, we will calculate the loss. Okay, loss will be y prediction minus y train. So once the loss is calculated, we will be doing the optimizer step. This is a third step. We are making the optimizer as a zero gradient and we are resetting it. Once that is done, we will do a backpropagation. Then after the backpropagation, we will be updating the gradient. That is, we will be using the optimizer dot step. Okay, so this is exactly what I mentioned earlier. So once that is done, we will be doing some evaluation. To evaluation, earlier we set it as a model dot train. So here we will be setting as a model dot evaluate. And for the evaluation or for the testing purpose, we will the test data will be using the test data and we will be predicting that, and we will be adding the test data to the the loss test loss to the test loss. Okay, we will calculate the test loss function, which will be result will be calculated to the test loss. Okay, then the next step is after every 10 epoch. Okay, after every 10 epoch, we are keeping the training loss and we are keeping the test loss and we are keeping the epoch count also. Okay, so why we are using the after every 10? Because we don't need to take like each and every epoch details. We are not planning to take. We are only plan to take like only like 10 epoch. Okay, at every 10 epoch, because usually like epoch will be like too big. Maybe we have to run like 500 times or 800 times. So keeping that will be not good, not recommended. So we will be taking like only periodically, maybe 10, 20 or 50 times based on the epoch size. Okay, so let's execute this. Some model training is happening. So we can see the loss. This is a training loss. Okay, so loss should be, so every time after every epoch we can see that the loss is reducing. Okay, so here also we can see loss is reducing, but sometimes it is increasing. Okay, because this is not properly converged. Okay, so once that is done, we can draw a diagram. Okay, so this is the training loss and this is the test loss diagram. Okay. Now let's see current value of our model. So let's execute it. Here we can see there is not much training is happened. So we can see that this is 2.26 and the bias is minus 0.445, but our actual one is 0.7 and 0.3. Okay, so let's do some prediction with respect to this model. So I'm doing some prediction. We are doing some evaluation and we are doing the prediction. Okay, now let's draw the diagram. Okay, so after the training we are getting a green, the red dots here, right? Now this is too far from our the original values, so which means our epoch size is not good, our training is not good, we have to work on it more. Okay, so what I'm going to do this time, I'm going to make it like 600 epochs, maybe like 700 epochs. Let's see how it progress. So the execution is in progress. I believe it is completed. Okay, so the execution is completed. Now I'm again repeating the same process. I'm going to check my prediction. Let's see my prediction, and I'm drawing it again with the prediction. Okay, here we can see it is little bit close, but not that much close, right? Okay, so what I can do, I can make it maybe 1000. Let's see how to perform. So this is completed. Let's execute it again and we'll see what is the predicted value. So now we can see after running it 1000 times, okay, we can see that now the red dots are very close to the green dots. Okay, now the model is learning, or model is converged to the what we expected. Okay, now let's see the weight and bias parameters of our model, latest model. I can do model dot state dictionary, model dot state dict can be print here. So we can see the weight is 0.7 and the tensor is, bias is 0.3. So this is almost, or this is same as that of the original values, right? So the model is trained perfectly fine and we are getting a good result. Now we will be going to our next step. So we completed the training part. Now what we need? Now we need to save the model, right? Model saving is very simple. Okay, so here I am defining some model path and I am giving the model name will be given here. And what I can do, the torch is providing a method called torch.save. Okay, so here I can pass the model state and I can pass the model path. Okay, so let's execute it. So this will be saved as a in a models folder. So if you come to the models folder, here we can see the model is saved fine, like linear regression dot PTH. Okay, so that is how it is saved now. Okay, so once that is saved, okay, we can easily load the model, okay, saved model with another function called the load state dictionary. Okay, we can use the torch.load function can be used here. Okay, so here what I'm doing, I'm creating the linear regression model again, loaded model. Then we can use loaded model dot load static, and I can use the torch.load to load the model from the path. So let's execute it. Okay, I just loaded the thing and let me print the details. So here we can see the weight and the bias are same, like 0.7, 0.7 and 0.3. Okay, so I think this is the end of this video. So let's do a recap. We have done a lot of things. We discussed a lot of areas. So first what we have done is we created a test data. Okay, then we split into train and test data. Okay, and we explain about how to build a model in a PyTorch. Okay, so this is the basic structure template that we will follow. Okay, right, then we discuss about how to train the model. Okay, so in the training model there are few steps. We need to predict the model, we need to calculate the loss, we need to set the optimizer to 0, then we need to do a backpropagation and we need to update the weight. For that we have to call the optimizer dot step. Okay, so once that is done, we saved the model and we loaded the model. Okay, so I hope it is clear. So if you have any questions, please put in the comment box. I will try to answer that. And for this video, I think this I explained in a high level, like backpropagation I explained in a high level, and forward pass, backward pass, everything explained in a high level. Okay, so I prefer like before, yeah, if you didn't clear about those things, please refer like a tutorials. You will get, there are a lot of tutorials available in the YouTube, because you just can refer for the depth knowledge. Okay, so that is all about in this video. Please do like and subscribe. Have a nice day. Also, I will be committing this code to the GitHub. You guys can download and try it out. Thank you.